Okay, this is going to be our second problem for the quiz, and I hope you pay attention. I think this will help you out a lot. So steel parts are heated in large industrial ovens in a tempering process prior to being installed in heavy equipment. After the parts are heated, the number of defects per part are noted for quality control purposes. An industrial manufacturer claims that their oven reduces the number of defects per part due to the new oven design. As a consequence of that claim, a heavy equipment manufacturing company is considering purchasing new ovens to replace their current ovens in order to reduce the number of defects. So we're looking to reduce the number of defects. The heavy equipment company, equipment manufacturing company runs a study to compare the number of defects produced by the two ovens. 250 parts were available for the study and were randomly assigned by coin flip to the two ovens. The results of the study are summarized in the table below. So first off, I look at this and I go, you know what? I have 250 parts, and I ended up with 125 in one oven and 125 in the other oven. Nothing was tested twice. So this is going to be a t-test for two sample. All right, we have two independent groups. We have the current oven and the new oven group, all right, with sample size here. And it says, the first thing it says is determine at the 5% significance level whether or not the number of industrial oven manufacturing claims are accurate. So here we go. We start off and we can write our null hypothesis mu1 equals mu2, or we could have said mu1 minus mu2 does not equal 0. We also say mu1 is greater than mu2. That doesn't help me if I don't know what my definitions are, which is why it's so important to have this. Some people want to do it first, and that's fine. So let mu1 equal the number of defects for the current oven. And so we're saying the current oven defects are greater than mu2, the number of defects for the new oven. Once again, you can express it either way. You need to know how to do that, just because you don't know how that's going to show up on a multiple choice or even on a free response test. All right, so conditions, random assignment of parts for both ovens was given. All right, they flipped a coin, right? They gave it by flipping a coin. The groups are independent. It's reasonable to assume that the number of defects from one oven does not impact that of the other oven. The two groups are independent. N is less than 10% for both ovens. So in this case, we had sample sizes of 125. So it's reasonable to assume that the population of parts for each oven is greater than 1250. The sample size is less than 10% of the population for both. Remember that we have that because we are sampling without replacement. And because we are sampling without replacement, things aren't truly independent. But we say that, you know what, the impacts are small, the impacts are negligible. So this is basically saying, yeah, it's not replacement, the percentages change, but they only change slightly. All right, the sample sizes for both groups is greater than 30. The distribution of the sample means are approximately normal for both. So we write down our formula. We have, and we plug in. Well, they gave us this information. All right, we didn't even have to calculate it this time, which is kind of nice. So we had the current oven had a mean number of effects. So this is my X bar 1. This is going to be S1. X bar 2, S2, N1, N2. And I'm just going to be plugging into this formula, okay? Please note I'm using a greater than, and the reason I'm using a greater than, that's what I have for my alternative, okay? So make sure you're consistent there. So I'm going to go ahead and run that through my calculator, and I go stat, oops, let me turn this on, stat, arrow over the word test. And I'm going to drop down to number 4, which is 2 sample t-test, and press enter. We're not using data, we're using statistics. So I need to input those statistics. And my X1 happens to be 33.56. My S1 was 5.2. My sample size was 125. My X2 was 32.44. My standard deviation of the second sample was 3.78. and my sample size for the second oven was 125. We had a greater than, and I always go back and check, make sure that you're consistent. Okay, so here I am, I'm consistent, so this needs to be a greater than symbol. We never pool. And I end up getting a T statistic of 1.9478. And since we had a greater than symbol, we're looking for the probability that T is greater than 1.9478. And we ended up with a p-value of 0.026. Our 0.0263 p-value is less than alpha of 0.05. So our decision will be to reject the null. So our p-value is 0.0263. We reject the null. There is sufficient evidence that alpha equal 0.05 to suggest the true population difference of mean number of defects is less for the new oven than for the current oven. Or we could say, or is greater for the current oven than the new oven. And our conclusion is the manufacturer, and make sure you always answer the question, the manufacturer's claim is accurate. How? The new oven reduces the number of defects. Yay, manufacturer. So they're happy because our study here showed that the manufacturer's claim is accurate. Maybe they'll sell new ovens. The next thing was to explain the p-value in context. So the p-value is the probability of getting a test statistic this extreme or more extreme given the null is true. This is the definition of a p-value. It doesn't get you points, but as one of my students so eloquently put, it's a good way of brown-nosing the graders so they think you know something. So if some of this other verbiage is off. So in this case, in other words, in our sample, there's a 2.63% chance. This happens to be my p-value, that we would get a test statistic this extreme or more in favor of the current oven having more defects than the new oven, when in fact there was no difference in the mean number of defects. Where did I get that? Well, having more defects, this came from HA. Because why? Because we said the current oven has more defects than the new oven, when in fact there was no difference. How do you come up with that? That's HO. Why? Because we said that the number of defects for the current oven equals that of the new. In other words, there was no difference. All right. So that's the way you put it in context. What type of error could we have committed? Well, we rejected null. So the only type of error we could have committed is a type 1 error. This is Mr. Spensey, your stats sensei. Study well for the test, and thank you for watching.